So as to Alpenglow, the kind of headline takeaway benefit is that it theoretically could reduce Solana's transaction finality time by 100x, some large x. And that's basically, how quickly does a user transaction become rooted in the network, as opposed to currently today, there's this optimistic finality thing going on. So we'll get into that. And I want to talk about how Alpenglow achieves that. And then maybe this could also be a window to just talk about how Solana works currently today. So let me just give you put you right in the deep end, Brennan. What is Alpenglow and how is it going to change Solana?
Yeah, so first, I guess before we get into the technical part, I think one of the most awesome things about Alpenglow is just kind of going to the spirit of Solana and how there are no sacred cows and how, we are our own biggest critics and how that's so important for just advancing the resiliency and performance of the network. So, we brought on this research team in Zurich, and they kind of got known because they published a pretty scandalous paper about some weaknesses with the existing system, the Tower BFT. And instead of, whining too much and begrudging them, it was awesome. Hey, do you want to come help us fix it? And they were really excited about that. So, Roger, Kobe, Quentin, that team over there is awesome and have really helped improve things. And so with the current system, the Tower BFT, there are a few issues. I mean, one is it's really hard to just prove from a mathematical level. It's been Band-Aid after Band-Aid on fork selection and how we kind of get the whole network pulling in the same direction when you have multiple blocks and multiple forks out there and things of that nature, which, when things are going well is very easy, but there are all these tiny, nasty little edge cases that manifest in the real world that you have to dig through. And so that's one problem. And then also by design, the finality is 12.8 seconds because we have this 32 deep tower, and I'm not going to go into all the nitty gritty details there, but kind of the gist is, even in the good case, 32 deep tower times 400 millisecond slot times is what gets you at this 12.8 second finality, which is kind of an eternity, especially if you're a Circle or Coinbase or someone that when you're kind of handling off-ramping, you really need to wait for that full finality. We kind of came up with this clever optimistic confirmation, which was maybe good enough for applications, updating the UI to kind of show a user, hey, this is basically landed. And that was significantly shorter, but still kind of on the order of, a second or so. So, okay, enter Alpenglow. There are a couple key things to mention there. So yes, you're right. I mean, the big headline thing is fast finality, like 100x improvement. We've probably spent more time debating the nomenclature on how we kind of represent what this thing is, as opposed to some of the actual implementation of how we achieve the finality. Some people have called it single slot finality, which is kind of a total misnomer because it really is out of band finality, and so it's decoupled from the actual Solana slot times that we have, because you have to observe the blocks. But then you're voting out of band and sending those votes to everyone. And so it's kind of more of a function of like the latency of the internet for when you can actually observe all those votes and consider a block confirmed or final. And so that's kind of the very high level of how things work and kind of the performance side, which is the big, sexy headliner. But just as important, at least for us, is the piece that hopefully people don't have to care about at all, which is the safety and security side of things. So with Alpenglow, one of the big differences is that we actually wait for these certifications before considering a fork valid. So currently with Tower BFT, you're just building blocks. Validators are observing votes, but they're kind of independently making their decision like, hey, I think this is the best fork to build on, and I'm just going to go, and hopefully the votes catch up with me and the cluster agrees. With Alpenglow, we have more of these hard cuts where we'll optimistically pipeline things, but we're waiting for that hard certification. Like, hey, I've observed 60% of the cluster voting here, 80% of the stake for finalization. Before I'm allowed to actually fully publish that block and have people consider it valid. And so if we do this right, we can still pipeline things very efficiently, but we also have that confidence. And so you don't really see forking in Alpenglow. And so it drastically simplifies the fork selection because it's really just, hey, is this block good or not? It's kind of a binary. It's made more synchronously, that decision. and away we go. So it simplifies a lot of things and gives us some of that safety and security.